This work is about how to use open satellite data to predict urban pedestrian activity. Alan Jacobs wrote many years ago a book titled Great Streets. What makes a street great? There are different elements. A street could be architecturally rich or could have, for example, small blocks. Here is an example between Venice and Irvine, very different type of blocks. And that contributes to very different pedestrian activity. Jean Jacobs theorized the elements that actually make a city great and create pedestrian activity. In her book, The Death and Life of Great American Cities, she theorized what are the elements that create death caused by elimination of pedestrian activity, highways construction, large-scale developments, what creates life for pedestrian activity all the time, for all the times of the day. And if we had to summarize and trivialize her 300 plus pages book, we would say that the four elements that create activity are mixed land use. You have a residential space, you have an office, you have clubs, all in the same district. That creates vitality all the time. Small blocks. I can see that the other person on the other side of the street. Age buildings, new building coexisting with old buildings. And then you have also a critical mass of people. We did in the past work at the DAP conference that showed that you can predict vitality from different data sources. And the ground truth data can be taken from phone data records. For example, we can see here that from phone data records, you can, and for the elements that Jane Jacobs theorized to be related to vitality, you can actually predict most of the vitality contained in mobile phone data records. Now, that requires a lot of time because you need to collect data from the census, data from the land use, data from a mapping company. What is then the data source, the single one that is publicly accessible and that could be easy to actually analyze? Satellite. So we went up the sky, and why we did that is because in 2014, the European Space Agency launched the first satellites under the Copernicus program. And this program aims at actually democratizing the access to have observation data. So if you take your city, every 5 to 7 days, the satellites will take a photograph of your city. And what do you do with that? Well, what we did is that we took photographs of 6 different cities in Italy, Milano, Torino, and Bologna in the north, and Firenze as well, then Roma in the center, and Palermo in the south. And then we built different deep learning models that are able to extract visual features from these satellite images to predict vitality. Just to understand what we did, take one of the cities we analyzed, Bologna. For Bologna, one massive image of satellite data was downloaded, one. This one image then, we divided into 620 imagelets, little images of 64 by 64 pixels. And why we can extract vitality from these little images? Well, just to give you anecdotically the reason why we think is a good idea, you can see that low vitality imagelets are green or gray, parks, forests, or gray, industrial zone, transportation hub, stadiums. Whereas the super high vitality areas, they're red in Bologna. Indeed, Bologna city center and residential areas are called Bologna, La Rossa, Bologna, the red. Then what did we do to train our deep learning model? Well, we matched this imagelet data with our ground truth data from the mobile phone record. And then we were able to take all these imagelets and predict vitality for the unseen imagelet. And then, of course, after you do that, you can do all sorts of arty things. And one of the things we did is that we basically order these imagelets by vitality levels. Most of the experiments and the serious stuff is in the paper, Jane Jacobs in the Sky, Predicting Urban Vitality with Open Satellite Data. I just want to show you one of the results, and that is leave one city out. We train our model on the 5 cities and to test it on the remaining city. As you can see, for most cities, the vitality can be predicted quite accurately, or at least to a certain extent. At least half of the variability, even of vitality, can be predicted purely from one satellite image. And why is that? Well, roofs might have the answer. Roofs give away urban activity. If you look at residential buildings, for example, depending on the materials that are used in these residential buildings, then you can have red roofs or white roofs. Red roofs in the northern part of Italy, for example, Bologna and Firenze, they use terracotta tiles. Whereas Palermo, which is the third image here, is white. Why is that? Because of the volcanic lava stone in South Palermo, in Sicily in general. And by contrast, one thing that is really boring, but is the same across all the cities, is the images taken from industrial areas. They're all the same, metal roofs. Incidentally, metal is far easier for satellite to detect because of the spectral characteristics. I would invite you to go on this website, social-dynamics.net/vitality. On this website, you will find the publication, part of the data, and the visualization. What is the visualization about? Well, as I said before, we order these imagelets by vitality levels. And you can see, for example, the urban spaces in very different position in different cities. So you can appreciate the unique signature of each city. But also you can access even part of the imagelets in this beautiful point list map. Each dots come with the dominant color of the imagelet and then with the corresponding vitality, predicted vitality level. You can do that for all the cities that we analyzed. And with that, I thank you very much for your attention.